Hi all, Ms. Z here, and today we're just going to do a little dilations review with any scale factor. So we'll do a whole number and we'll do a fraction as well. And my little girl just brought me some flowers from outside, so I decided, to include them in the video. But our essential statement is I can dilate a figure using any scale factor. All right, so here is our example. Here we have triangle ABC. Go ahead and draw that down. I also included the points ABC for you right over here in case you needed those points to plot your triangle. Now we have triangle ABC, and our question is asking us to dilate triangle ABC by a scale factor of 2. So if we think back to what the scale factor does to our original figure, we know that you need to take the scale factor and multiply everything inside the ordered pair to get your new coordinates. So if I take point A, which is at 0, 1, my new A prime would be anything times 0 is 0. And 1 times 2 is 2. And then my B prime, oops, I know, there goes Miss Z again, flexing with her erasable pens. B prime, so 2 times 2 is 4, and 3 times 2 is a 6. So remember, you take the scale factor and you multiply your ordered pairs to get your to get your transformed image. And then C prime, -2 times 2 is -4, and 3 times 2 is also 6. And once you have your new points, you go ahead and plot those. So 0, 2, so right here, okay, it's A prime. 4, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Right here, that's B prime. Should make another unit. And then C prime is -4, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So if you notice, these triangles are similar, but they are not the same size. For dilations, the size changes. So let's go ahead and connect these points. And there is our dilated image. Okay, now we'll do an example with a scale factor that is less than 1. So here we have triangle TUV, and we're going to dilate triangle TUV by a scale factor of 1/3. Like I said earlier, I will give you fractions that are pretty easy to work with in this case, and normally math teachers don't really hate you guys as much as you would like to think so we try to have the problems work out in your favor. I also wrote down what the points of TUV are. So what we're going to do is we're going to take our points and we're going to multiply by the scale factor of 1/3. So anything times 0 should be 0, yes. So that's T prime, 0. And then 6 times 1/3, or 6 divided by 3, is 2. Now, a side note right here, if you want to know how to multiply this out, you have 6 times 1/3. Remember, you multiply across, but you need to make the 6 into a fraction. And the way you do so is by putting it over 1. Once you put it over 1, it's 6/1 times 1/3. And for multiplying fractions, you just multiply across. So 6 times 1 is 6, and 1 times 3 is 3. And then you simplify that, so 6/3 becomes 2. And that is how we got 2. Next, u prime, 3 times 1/3, or 3 divided by 3 is just 1, and then it's the same thing because it's the same number. And for v prime, here it gets a little tricky. So, -1 times 1/3. First of all, if you think about it, 1 times anything is, drum roll please, is anything, okay? So 1 times 10 is 10. 1 times 30 is 30. 1 times 2/5 is 2/5. So 1 times 1/3 is 1/3, but here it's negative, so really it's -1/3. And then -3 times 1/3 is just -1. And then we're going to go ahead and plot our points. So 0, 2 is t prime. 1, 1 is u prime. And -1/3, -1. So you start at the origin, and it's -1/3. So you're going to move to the left 1/3. You don't go to 1. 1/3 is somewhere right here. And then you go down 1 for v prime. And then you go ahead and connect. And there we have our dilated image triangle TUV prime. And that is it for Dilations review.